Hi, today let's look at multiplying and dividing radicals, and let's see what kind of things we get into. There's a few rules that will help smooth that out for us. Oh, here comes our friend Hilbert here. I wonder what he's up to. Well, he's shooting something out of the top of his head there, a little ball-like thing. Oh, got a duck. Oh, it's the Bernoulli brothers. They're bringing us a problem to do here. It says the square root of 4 times the square root of 4. Now, we can go ahead and work out each one of those square roots individually, and so we'll get 2 times 2, which equals 4. But what I want to do is go over a couple rules that we can use to simplify that process a little bit. Let's say that we have the square root of x times the square root of y. In this case, what we can do is multiply the x and the y together and put it under one radical. So that's something that we can do. Now, let's go sort of the other way. Let's say we have the square root of 25. We can pull that apart, and we can say that we have the square root of 5 times the square root of 5. And we know that the square root of 25 is 5, so the square root of 5 times the square root of 5 equals 5. Now, so, look, the square root of 5s are the same. When you multiply them together, you just get 5. So let's say we have the square root of x times the square root of x. We know that that's just the square root of x squared, and that's just x. So the square root of x times the square root of x is just x. Whenever you have your like radicals like that, you can do that kind of thing. Let's look at this problem here. We're going to multiply the square root of 3 times what's in the parentheses there. But first, let's take that 27 and change it to a 9, because it's a square, and so we can pull out a 3. And then we're going, using the distributive property, multiply the square root of 3 times each one of those terms inside the parentheses. Now, wherever you see a square root of 3 times the square root of 3, that just becomes 3. So, in the end here, we'll get 3 times 3 minus 3, which is a 9 minus 3, which gives us 6. So all that stuff at the top there boiled down to be just 6. The next problem here, done this similar sort of way here. Take the square root of y, using the distributive property, multiply that times each term. The square root of y times the square root of y is just going to be y. And then the square root of y times the square root of 5, you can just combine those terms in there and get 5y. So under one radical, and so we'll get y minus the square root of 5y. Oh, there, I don't have to duck. Here's another one of the Bernoulli brothers. He's bringing us a problem. It's a square. Now, what we can do with this square, we can take and make it 2 factors. So we have the square root of x plus 4 times itself. Now, let's apply that FOIL property where we'll apply the first terms together, the outer terms together, the inner terms, and the last terms together. Now, we see the square root of 2x times the square root of 2x is just going to be 2x, and then we'll get 8 times the square root of 2x, and then 4 times 4 is just 16. Let's apply the FOIL property here in this case. So let's multiply the square root of y times the square root of y, and then let's multiply 2 times the square root of y, and then a negative 2 times the square root of y, and then a negative 2 times 2. So the square root of y is just give you y, and the inner terms there just drop out, and then we have a negative 4 on the tail end there. So we get y minus 4. Now we're getting into a division which can be represented as a fraction. Now, what we need to do in this case is get rid of the radical in the denominator to simplify. So what we can do is multiply the square root of 5 times both the numerator and denominator, and you'll end up with the square root of 5 over 5. Next case, do the similar type thing. take the square root of 3a and multiply it times both the numerator and denominator. So in the denominator, by our rules there, we just get 3a. In the numerator, we get 9 times the square root of 3a. And we can do a little canceling there. And we'll end up with 3 times the square root of 3a over a. This one here, you can rewrite that so that you have the square root of x over the square root of 5. And then do what we just were doing. Let's take and multiply the square root of 5 times the denominator and square root of 5 times the numerator. And in the end here, we'll get the square root of 5x over 5. Now in this next problem here, we have to use a little special method here, using what's called the conjugate of the denominator. The square root of y minus 2, its conjugate is the square root of y plus 2. Now take and multiply that times both the numerator and denominator, and you'll see how well it simplifies the denominator. So in the denominator, use the FOIL method, multiply that all out, and in the end, you will find out that you have the 3 times the square root of y plus 6 over y minus 4. Now in our last problem here, we're going to be dealing with a cube root. Now what you need to do to simplify this denominator a little bit is you need to get cubes underneath the radical. So let's start out with changing that 4 to a 2 squared. Now let's take and multiply the cube root of 2x squared times both the numerator and denominator. And what that will cause to happen is that the denominator will have a cube root of a cube of cubes. The cube's 2 cubed and x cubed. And so those will just fall out and you just get 2x. So you'll end up with 3 halves times the cube root of 2x squared. Thank you.